So before we get started real quick, I'd like to take a quick poll. By show of hands, how many people before this talk had heard about Bitcoin script? Excellent, we're good. Okay, so we got people paying attention, that's good. Who has tried to learn Bitcoin script? Right, okay, just a few more hands. Has anyone here ever written a locking or unlocking script for Bitcoin? All right, got like 5, wow, okay. So hopefully by the end of this talk, you'll all have checked that box. I'm going to show you some nice tooling that will make that a lot easier. So real quick before I get into the talk itself, I just want to mention, I'm going to say Bitcoin here, but what I mean that everything here will actually work for all of the chains mentioned, BTC, BCH, and BSV. All the tooling I'm going to show works for all of them, and all of the discussion applies to all of them. So for our purposes, no serious difference. So with that, we'll get started with the basics. I'm going to start with some of the very basics. Of course, Bitcoin is stored in wallets. There are lots and lots of wallet options. You can get wallets for your iOS, Android, Mac, Windows, Linux, etc. Lots of apps you can download. And of those wallets, most of them are of the top variety here. So there are 2 primary security options you can get right now in the Bitcoin wallet world. The first one is a single device wallet, and this is what most people recognize as a wallet when they talk about a Bitcoin wallet. This is a wallet where you send some Bitcoin to your phone or to your laptop or whatever, and then when you want to spend Bitcoin, you open that back up and send Bitcoin using that device, and right when you press send, the money goes. So that is, there's another variation, which is significantly more secure. We call them multi-device wallets. In this case, they're P2SH multisig. Multi-device wallets are significantly more secure in that you can have multiple devices required to sign in order to send money. So what that actually means is, has anybody heard of the Copay Bitcoin wallet or the BitPay wallet? A few, okay, good stuff, yes. So those wallets are actually some of the only ones right now available on the market that are using the second variant. So you can have, for example, you can have a wallet on your phone and on your laptop, and when you want to send money, you start sending, scan the QR code on your phone and press send, and you get a notification on your laptop, and you have to click on that and open up the app and review what the transaction is going to be, and if you're okay with that, you press send on your laptop. And so both devices have to agree in order for the money to be sent. So that makes things significantly more secure, because if one of the devices is compromised, then the other one will still prevent the attacker from taking your money. So multi-device is a fantastic way of adding significantly more security, and it's like an order of magnitude better basically every device you add, depending on how you do it. So those are the 2 primary options, but there's an interesting question. So what if one of those 2 options doesn't quite fit your use case? And Bitcoin has a really cool way of handling that, and I'm going to talk about it a little bit more. So as an example, imagine you're starting a new Bitcoin exchange, and you've got 2 founders, and what you're trying to figure out is how you can have that multi-device wallet for this, maybe your production hot wallet, and you want to make sure that if your CEO drops his phone in the lake or something like that, or disappears, then you can still get your money. So the co-founders maybe decide that they're going to have a 2 of 2 wallet, so both of them have to sign. However, it would be really cool if they could have some sort of recovery option, so that if one of them disappears, or seems to disappear, then a trusted party, in our case, we're a Bitcoin exchange in Canada, so we have a lawyer who can sign for us 30 days after one of the co-founders disappears. So this is actually quite cool, because Bitcoin provides a really, really nice way of providing for pretty interesting and different authentication schemes like this. And that is called Bitcoin script. Bitcoin script is a programming language for authentication. So I'm going to describe it a little bit more, and we're going to go into some more basics before we get into the actual programming part. But to get a little bit further, we're going to start with some basics on Bitcoin transactions. So, you know, Bitcoin is a big system for keeping track of lots of transactions. Bitcoin transactions go from some addresses to other addresses. They have inputs and outputs. You take a pot of money here and you spread it out amongst addresses you want to send to. And the batch in which you do that, we call a transaction. Inputs to outputs, right? So this is actually what a transaction looks like. It is a block of data that looks a little bit like that. And here I've highlighted some of the individual pieces. On the next slide, we're going to break it out a little bit more. But I wanted to show you this so that you have an idea of kind of where we're getting to. When we write scripts, we're actually writing a big piece of what's in this transaction. And here you'll see, for example, so this is that same transaction broken out. You can see at the top there is the version of the transaction. It's a 1. There are 4 bytes available, and we're using the first one in this case. The next number down is the number of inputs. The next 4 items there, the TXID, the outpoint index, unlocking script, and sequence number, those are all things that are part of the input. So that tells everybody you're sending the transaction to what transaction ID you're getting the money from, and which outpoint index of that. Then there's an unlocking script there. And then below we see a number of outputs. The number is 3. And 3 sequences of a locking script and a value, a locking script value, locking script value. So you don't need to know too much about this to understand the rest of the talk, but I wanted to give you an idea of what we're getting to when we write scripts. If I hover over here, you can see the things I've highlighted here is on the top there, I highlighted the unlocking script, and the bottom 3 blue things are locking scripts. So I'm going to dig into a little bit of what those actually are and what they mean. I just wanted to highlight, if you look around everything that's highlighted right now, you see like mostly zeros. There's a few other numbers. There's a version and some of the other, the values and stuff. But for the most part, the contents of a transaction are these scripts. And that's how we keep track of what's happening. So we're going to decode one of those locking scripts. This is that top locking script from the last screen. And I just want to give you an idea of how the system looks at this before we start trying to write them ourselves. You can see it starts with a 76, A9, 14. So when the Bitcoin virtual machine is reading locking scripts, it's reading them 1 byte at a time. And there are 256 spots, I guess, for instructions. Only about 150 of them are used. But each one of these bytes, so the 76 maps to an instruction, A9 maps to an instruction, 14 maps to an instruction. So I've spread it out here a little bit more. Notably, some instructions do things, and some instructions are ways of telling the system to now read the next amount of information as data. And here, 76 and A9 are normal instructions, and 14 happens to be a push instruction, which tells it to read, coincidentally, 20 bytes after it, and then 88 AC are both instructions. So if we break that down one more time, this is the kind of human representation of what's going on there. This is the disassembled version of what's above. You can see opdupe maps actually to the hex 76. Op hash 160 maps to the hex A9, hexadecimal encoded. Push bytes is 14. There's some data stuff. Op equal verifies 88. Op check sig is AC. I'm going to describe these a little bit more, but I wanted you to see how instructions, the byte code maps to a name here, and it's coincidentally in action. So one final thing you need to know to understand Bitcoin scripts and the rest of our kind of interactive part of this talk is a stack. So Bitcoin operates on this hypothetical stack. You can imagine it like kind of a bucket. In this example over here, I've got a bucket on the far left, and it's empty. This is what it looks like before we start executing a script. And below you see there's a 1. That's how we indicate that you push a 1 by putting the less than and greater than signs around it. So if you push a 1, then you get a 1 on the stack. And then we scoot over 1, and the next frame we see that you're pushing a 2, and you get a 2 on the stack. And then the final frame, this is an example of an instruction that does something. So what it does, we say it pops the top two things off the stack. We call it popping. So we pop a 2. In this case, it's a 2 and a 1. And we have those numbers. And op-add adds those numbers together and puts them back on the stack. So this is a very simple example, but we put a 1 on the stack, then we put a 2 on the stack, and then we add them, and we take those two, put them together, and put them back on. So everything in Bitcoin is happening in this little bucket, and a few other little things. But for the most part, this is pretty much all you need to understand conceptually to understand any of the opcodes. And then after that, you're just kind of learning what each one does, right? So now it's demo time. So I will, let me see if I can, no, there we are. I'm going to show you, this is an open source project I've been working on for a little while. This is Bitauth IDE. It is an interactive development environment for Bitcoin script. You can see, and I'll actually switch over to our demo mode here. It has an interactive editor. It has a language of its own, Bitauth script, and you can write in a pretty human way to describe Bitcoin transactions. It supports variables, keys, and signing. There's some other fun stuff that we're going to get into. But I'm going to start on this screen, and actually, it'll be a lot easier for you to see if I crank up that size for a minute. Let's go there. There we are. Right, so you can see I've already typed op1 here, and that actually happens to be an instruction that pushes a 1. It's a single byte, it's encoded as the number 81, or hexadecimal, it's 51. But it's an instruction that pushes a 1 to the stack. So if you can see, does this zoom when I, oh, it's unfortunate I can't zoom. Right, okay. So if I hover over the 1, you'll see that on the stack, the 1 is actually represented as the binary 0, 1. So you can see that when I hover there, we get an indication of what's actually going on. So I'm going to go in this editor and show you, I just typed a less than symbol, and it added a right greater than symbol. And inside there, I'm just going to type 1, 2, 3, 4. So you can see, up here we pushed a 1, and here I'm pushing a 1, 2, 3, 4. And I can hover over it in the stack, and you'll see 1, 2, 3, 4 represented in a hexadecimal is 0xD204. You don't need to know that, but so just to show you. And now I can do something like I can op drop, and now we just have the 1. And I can push, for example, I can push hexadecimal literals. I can do something like, push 1, 2 through 0 there, and you can see on the stack, we now have a 0x 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that's a quick overview of kind of what this looks like. I'll go ahead and flip now to one that I've written a little bit more so you can see what's going on. In this example, we have op1, which pushes a 1, and then I've op-dropped the 1. Op-drop, I don't think I showed it before, but op-drop pops the top element from the stack and discards it. So you can hover over that and see that. Op1 pushes the script number 1 onto the stack. So this is a nice tool to see what's going on. Down here you can see we push a 1 on the stack, we drop it, we push a hex literal. You can see that worked as well. I'm dropping that. Here, this is a little bit more interesting. So everything in here is kind of recursive. You can actually, in this example, you can push the bytecode representation of op1 to the stack. And that sounds a little bit weird, but it's actually important for a few other things, and I'll show you later in the presentation. But just so you've seen it here, everything that you're writing here maps to some binary, and we can actually operate on that binary and move it around and stuff like that. So that's important if you want to like hash it and do some other things. So in this example, as I mentioned before, op1 is opcode. It's the 81st opcode. You don't need to know that, but the hexadecimal representation for it is 51. There it is. I dropped that, so you can see we're just adding stuff to the stack and removing it just as we're going down this page. The final thing there, I just wanted to show, this language also supports string literals. So you can push the UTF representation of strings. In this case, it's you can see it's 61, 62, 63, and then a 20. 61 is A, 62 is B, 63 is C. That's how it's encoded, and if you dig into most text files. A 20 is a space, and the thumbs up is the last part there. So just wanted to show you all the things you can do here. So let's get to the simple math. We've already seen this example. Here we're pushing a 1, pushing a 2, and then op adding. And I can put an enter here so you can see what's going on. So if you'll remember, we had a 1, then we had a 1 and a 2 on the stack, and then after that we ended up with a 3 after the op add. So let's consider if I add a push of a 3, and then I type op equal. There we go. So this is now a little bit of an equation. I have 1 plus 2 equals 3. And I'm written in the weird stack-based way where you put the operation at the end and the stuff you're doing at the beginning. So we push a 1, push a 2, we add it together, and then we push a 3 and check that the result is 3. So to break it out a little bit more, let's call everything below this line a locking script. So in the Bitcoin system, when you send money to the second half of an equation. And the equation is written in Bitcoin script. So you can send money to this thing, and then in order to spend that money, you would need the unlocking script up here. In this case, the unlocking script is a 1, so your money is quite insecure. But we'll talk a little bit more about other things you can do. So this editor has a really nice mode for locking and unlocking scripts. We actually put the unlocking script above the locking script so you can see how it works as you're looking down. So this is what we were just looking at, but now displayed fully. So the top there is the unlocking script, and you can see I've called it just a 1 because it's just a 1. And the locking script I've called first validation. Just an example here, and if I put an enter there, you can see that we've pushed a 3 and compared that what we got as a result from the top is a 3. And so just as an example, if I was trying to spend this money and I tried to spend it with an unlocking script that had a push of a 0, it would be invalid. You can see down here that when we try to op equal 2 and 3, if we try to compare the numbers 2 and 3, they're not equal, and so we get a 0. And so the transaction would be invalid. Transactions are only valid if the result is not a 0 when you've fully evaluated it. So now you understand exactly how the unlocking and locking scripts work together there. So I'm just going to show you a few more examples. This one's a little bit more interesting now. So this is at the top is an unlocking script where we push a 1. On the bottom, this is starting to look a little more interesting. We've got an op hash 160, which I can hover over. You can see it's pop the top element off the stack and then pass it through SHA-256, then ripen D160, both hashing functions, and then we push that result onto the stack. So the hash 160 of the number 1 is this big long thing. And then we've got this strange construction in the middle, and then we've got another op equal. So I'm going to put this over here so you can see it spread out properly now. So what we're doing is we push a 1, we hash it, and then we push something else and check that those things are equal. Now what happens inside this something else is the other interesting thing about this scripting, about Bitauth script, the language that I'm writing in. There's an internal evaluation, and this is a way for us to use the Bitcoin virtual machine to go ahead and write some of our code for us. So here, what I've done is I push a 1, and then I hash it. And then the result of that is what actually gets included in the first script. So what we've got is, up here we now have a hash of 160. We have a push of the hash of the hash 160 of the number 1, and then we check that those two things are equal. So I'm going to move on. This is still not quite secure, though. If you tried to send money to this, other people might not be able to figure out what number you hashed in order to use as your private key. If I put a 0 here, you can see if I mess around here, the two numbers are quite different. If I hash a 1, I get that first half. If I hash a 0, I get this. A 6, I get something totally different. See, it's very difficult to reverse a hash. So this is quite secure, except if you try to send money this way, a miner could still steal it. Here's a real example. We can push, this is a quick example of what the variable system looks like. In here, I have a key called my. You can see on the left, there's the entities, there's a JSON. JSON has my, and my is a key. So I'm pushing a signature from the key my. And here I push the public key for that key, and then I use this check sig operation. So we have on the stack a signature and a public key. And check sig takes those two things and checks that the signature is signed by the right person. So this is how the most basic of Bitcoin transactions actually works. You could send money to the second script, and it would actually be secure. So that's the basics. And I'll just show one final thing. This is how conditionals work. Again, note this is a script system, so if I push, if you're used to any other programming languages maybe, you usually write an if statement. You'll type if, and then the condition that must execute to get the if. But here you'll notice we kind of switched everything around. It's a stack-based thing, so the if can only operate on stuff that's already on the stack. So to do an if in Bitcoin, you actually put it before the if. So here I put a 0 before the if, and then if reads what's on the stack. I can hover, I can hover over here and you can see, so on the stack is an empty object, which is 0. And then we op if, that takes the thing off the stack and sees, is this a 0? And if it's not a 0, it would execute it. In this case, it is a 0, so it skips this thing. Then op else actually takes a look at whether or not we're currently executing, and it just does the opposite. So that's how the Bitcoin script conditionals work. Here, I get out of that. Here I push a 2, so you can see over here we've got lines. Yeah, you can see over here the top part is not executing, the next part is executing, and each progressive op else flips whether or not it's executing. Now, this is a little bit of a contrived example because you wouldn't actually want to do this. Instead, we can simplify this a lot. I can put the 3 up there and the 4 right there and delete these 2 random op else's. And now this is a little bit easier to understand. If I push a 0, it's not going to execute. If I push something else, you can see that it's just changed what it showed on the screen there. So here we're executing the second half, and here we're executing the first half. So you can see that in the stack on the side there. So that's a lightning tour of Bitcoin script. And I just want to cover real quick. So what I've shown you is Bitauth IDE. It's a low-level, it includes a low-level language for Bitcoin script. It has a compiler with support for variables and signing, and an IDE with a line-by-line debugger. So thank you very much for your attention, and any questions?
You have the script that's just in one. You have set an empty unlocking script.
Yes, exactly, actually. You're totally right. You can send money to a locking script where it's just a push of 1, and then anyone can spend it. And that's a lot of people will refer to those as anyone can send or opt-true outputs. And it's in fact how SegWit was included as a soft fork. So yes, that is a very astute question. And yes, you can send money to a locking script, which is impossible to not spend. So you can just, it's kind of like just throwing money in the air. Right. Right. Yeah, so there are some other languages that compile are slightly higher level and compile the Bitcoin script. What I've done here is created a very, very low level abstraction over what is normally Bitcoin script. So anything you can do with Bitcoin script, you can definitely do here. So this is a slightly higher level, some good tooling to work on the base layer, but there are some other exciting projects that we should talk afterwards, because it looks like I'm getting called off. But thank you all very much.